Hello everyone, today I'll talk about the solution to the problem kth largest element in a stream. So feel free to pause the video and read the statement. Since you want to maintain the kth largest element in a stream, then one way would be to maintain all the numbers that we've seen and use a data structure that allows us to find the kth largest element. I don't think there is a data structure that can do it easily. Maybe a sorted list from sorted container. Because if you want to maintain a sorted list, then it has to be represented as a binary search tree, and a binary search tree that allows us to find the kth largest element, which is something that some binary search trees do not allow us to do, because you need some extra information in the nodes, for instance the size of the subtree of the node. So that is one way, and of course you can also maintain just the sorted list, but then if the insertion order is not good, then you might have to change a lot of the list every time you insert a new element. One easy thing to notice that will make this problem easier is that we can only maintain k largest elements, and then always the answer will be the smallest element there. So for instance, the first element of our list. And the problem with, if it's still a list, of maintaining the order still exists. However, now at least we do not have to search for the element. And also if it's a binary search tree, you can just return the leftmost element. However, an easier solution and more in line with this problem is to use a heap, to use a priority queue. That's because priority queues are exactly built to solve problems like this. You want to maintain the k largest elements that we've seen previously and be able to say what the smallest element is. And now when we see a new element, we add it to our priority queue and we remove the smallest element from the priority queue. Maybe that element is the element we've just inserted. And this is just the solution. So we take the nums that were given, we turn them into a heap, we remember k, and now we just remove elements so that we have at most k elements in our starting heap. So to create a heap in linear time, we used a heapify function from heap queue, heap pop if we want to remove an element, heap push, which is the first thing we do when we see a new element in add. We add the element to the priority queue, and if priority queue has more now than k elements, we have to remove the smallest element. And of course we return the element at position 0, because that is the heap property. So that is the simplest way of solving this problem.